Okay.
Did you get a notice it's
I
being?
did. Yeah, but it said recording in progress.
All right, so that's good. Somebody's in chat. Who's in chat? Oh, that's you.
Yeah. Can you see me,
I
Charlie?
can see you. Yep.
Oh, you can? Okay. Weird. I can't see myself. Usually there's like a screen where you can see yourself too, but that's okay. I don't need to see me.
Yeah, that would be under video settings, I think.
Well, yeah, I mean, it shows that my video is, working,
How
but
about under participants?
I think it might be under view. Let me see if I can do. There we go. Okay. I changed my
Fine.
view setting. Yeah, I was only seeing the speaker and the gallery on my view.
I find it really unnerving when I can't see anyone, and
I know.
it's
You're talking to a vast, you don't
yeah,
know who's there. Yeah.
it's like worse than a disc jockey, I think.
Yeah, because you know that there's people listening and you just have no idea what their reaction is or anything.
Yeah,
It's tough.
I don't think I could ever be a disc jockey. It's talking into the void. I guess you gotta like talking to yourself.
I think so. You know what, my dad was all through high school, actually. He was a disc jockey and then in college too.
Uh,
Yeah.
all right, so you can see the screen now, right?
Yes.
And because I don't have a green line around it like I usually do, so I don't.
Oh, yeah.
I think as soon as I open up something, I open up and that goes away. But it doesn't matter as long as you can see it.
Yep, I can see it.
Yeah, I think you can start letting people in.
Okay.
I don't. I don't know if we're gonna have as many as we did last time or not.
Yeah, I don't know. You posted it on your Facebook page, right?
Yeah.
Because I shared that, but
And
I don't know how many people
I
saw
posted
that.
this
We'll
in
see.
6 different groups on Facebook.
Oh,
So you
good.
should.
Okay. Good. Well, I will go ahead and let people in here.
Great.
Let's see. Admit all. Good afternoon, everybody. Welcome to part 2. I'm curious to see if you participated in part 1. Put in the chat yes.
Yeah, that's a good idea.
Just curious.
Dusty.
Yeah. We'll admit Dusty.
But nobody knew
There's
that
Don. Don's
person.
waving. Hi, Don.
Can you hear me?
Yeah.
Unfortunately.
Not nice. So I got my class done in time because a few of the students wanted to join this. So
Oh, cool.
you're gonna get to chat at the class. So I'll mute myself out here so I'm not being terrible, but in episode I'll let you know.
Okay.
Nice.
Cool.
So cool.
Wonderful. Looks like we have a lot of most of the people that have that are here now were present for the first part.
So
Well,
question on that, are you guys gonna publish that first one?
I don't know yet what I'm gonna do with that.
You're getting I have a lot of people want to see it.
How much are they willing to pay?
Oh, that's mean.
Yeah, I don't. So
you capitalist, Buell.
I'll think.
It's
I'll think
the
about
farthest from Charlie.
Well,
He's burning now.
I didn't really
Voting.
I never intended to do much with it, but it's kind of stuff for my kids, maybe.
Right. Yeah, it was pretty cool.
But I'll well, the number of people we have on here will somewhat hinge on how much time I spend because I was gonna kind of do a recap a bit on and start back with some of the basic science side of it, and we can hasten through a lot of that then and get a little shorter. But
Jump in from
Yeah.
there.
yeah,
Yep.
so we've
Cool.
got Mr. Dusty. Are you multitasking, Dusty?
Definitely multitasking.
Are you were you at the last one?
Oh, sorry. No, no, I didn't get to join the last one.
Okay. All right. So
Come on, Dusty, put your face on so we can see it.
I'm trying to get in a spot where I'm not around a bunch of people.
Who cares? Just
Who cares?
yeah.
there's my sweetie coming in. I scolded her for not coming last time.
Let's see if I can move it over.
Oh, is this your better half?
Yeah, that's my better half.
Oh, nice.
How do I get?
I don't know if any of my
I'm gonna
kids will
have to
be
just
here.
go
One's in
in here.
Tennessee and one's in I don't know where he is. But, Dylan said he's going to be a hair
we go.
late.
Wouldn't let me pop over.
I'm gonna mute Don for a second because
That
he's
sounds
away
like
from
a
his
good plan.
his screen, but he's still talking.
Yeah, it looks. Yeah, all right.
Sorry, Don, I muted you.
Not nice.
I'm really glad to see Julie here. She's in the other room.
Oh, hey, Jules.
Hey. Hey,
Nice to
Donnie.
meet you, Julie.
Nice to meet you too.
All right. And there's Mark. I don't think you've met Mark. Mark, Zone
Hi,
5
Julie.
Construction.
Hi.
She's
everybody.
listened to me talk to Mark, but
Oh,
Yeah.
that's right. Is
Yeah.
that one of
Yeah.
those guys again? Yeah.
yeah.
I call him at all hours and especially early in the morning because I'm 2 hours ahead of you. So, at 6, you're still
Yeah.
at 4.
He's
So-
awake though. He's
What I
awake.
think is if I'm up, he should be up.
I love all you East Coast guys because I can call you on my walk at 5 in the morning. All right. Well, let's get started here. It's
good.
smaller group than last time, but we'll recap some of the stuff I talked about last time, and we'll zip through this stuff here. So I modified this a little bit because it's not just for cold climates. These same principles will work well in any climate, in my opinion. I've often wondered why in the South they've never been interested in insulating their houses. They just still just as valuable to insulate for cooling as it is for heating. But we'll talk a little bit about that later. Right. What gets in the way of building better? I've shortened this a little bit and consolidated some of it. This was in the first presentation, but there's a lot of thinking it can't be done. That's always gets in the way. Of course, my Don Quixote, I'm often accused of being Don Quixote. I'm trying to get people on board with some of these ideas. Thinking it must be more expensive. It doesn't have to be. I was building houses in the 80s with 10-inch thick walls that were cheaper than conventional houses, 2x4 houses in the same area. So it's just not necessarily more expensive. People want to maintain a perceived standard of living and keep up with the Joneses. If you want to keep up with the Joneses, you're going to spend, it's going to cost you money. People think the Earth's resources are free. They're really not. Energy efficiency of a 2-person, 6,000 square foot house is perhaps an oxymoron. If we learn to save $2,000 on our heating bills, only to justify spending more money on a bigger house until we get back up to that $2,000 that we saved, supposedly gained, uh, uh, what have we gained? Nothing. It's cost us more, and plus the additional resources consumed to build that bigger and better house. But you see that play out in a lot of things. People think they're saving money, so they can use more stuff because they're saving in A, they can spend it on B. So there's a whole psychology of energy conservation and building green that we necessarily have to deal with. And so it gets political. We talked about the politics of it last time as well.
You haven't lost anyone from that statement, Charles. We have 10 participants still.
Yeah, well, that's good. That's good. I'll try to keep my politics in check, even though it's annoying to do so. People want, demand, and expect cheap fuel. You see that with gasoline prices. It's everybody thinks that we should spend 25 cents a gallon, right? And we have a right to. But it's the government and technology's job to ensure that that happens. Too much is never enough. A good point in terms of trying to save energy and build efficient houses. So this was the house I built in 1979. I think you all remember that. I took out some of we talked about the post missing there and this type of electric meter that we don't see very many of anymore. This was 1979. It was the house that this 1979 NYSERDA, this New York State Energy Research and Development Administration. Aren't you glad they shortened that one down?
Oh, I'm impressed you remember what it stands for.
I know, but I tell you, when I was doing this project, you knew what it was. And it was like they were at the forefront of what is now known as the Green Movement back in the 70s. Everybody knew who NYSERDA was.
Are they still around with a different name? Do you know?
That's a good question. I don't know. I know that when Ashy published my article about a reasoned indictment of the Green Movement, that article, I had to get permission from them to use my own information in that book. It was kind of a copyright thing. They had to jump through. This is that house, and we talked about that it was a hydronic baseboard. The article says it's heated by oil. It was not heated by oil. It was a 30-gallon electric water heater that hydronic heat for both sides of this building. It didn't have any solar collector on it. I don't know where they got that. They made up some stuff, highly repeatable. I like that. That's the best thing in the whole article about my house, that it's a highly repeatable ideas. And I think that's really important in building houses. We can all think of houses that aren't so easily repeatable ideas that people try to promote.
And Charlie, was that house $66,000 to build, or is that what they sold it for, or what you sold it for?
That was the cost to build it. Yeah.
Okay.
That was my contract on the house. Yeah.
That's pretty awesome. Today's standards, that equates to $280,000.
Yeah, still kind of cheap.
Very cheap.
Yeah.
Yeah.
Yeah. So this is these are their drawings, so they did a pretty nice job of displaying all this in the book. All of these windows in the whole building had these insulated shutters on them. They were on the inside. So in this area, there would be a recess in the 2x8 framing. So that particular area would be 2x6 in that area. And that's what the shutter was slid into. It slides in like that and slides back like that. So it's an idea that I played around with in two houses. I put these in and decided that they're too much work. You know, people aren't going to use them because there's just no way to make them absolutely weather sealed like a refrigerator. That's how sealed it would have to be for glass that can get down to 30 below zero to not condense any leakage that you would get into that space from the interior. So if you're going to do insulated shutters on a building, they need to be on the outside of the thermal envelope, not inside. So that was something good I learned out of all this. This is a little picture of the basic theory of how my houses work. The idea was to get this heavily insulated bubble down into the ground below frost level so that the base of it is in constant ground contact with year-round 50, 55 degrees. And therefore, you should have a much higher starting temperature than ambient. And you could think of, you can see up here it says 110 to minus 30 degrees. If you've got a heat or cool from either of these temperatures, it's a long ways if you cut this building off from that constant ground temperature, either for heating or cooling. So that's how they worked and why they were successful. I made some new drawings to kind of bring it up to a little bit more where I'd like to see the standards, the standard of construction go. So here's our house here, and we've got R70 in the attic, R48 in sidewalls, and that carries all the way down into the ground below frost level.
Hey, Charlie. Charlie,
yeah.
that dirt layer on top is pretty important. If you don't have that dirt layer, frost could go down through that gravel and freeze the bottom. We've had some of that where in a window well, somebody they just put gravel all the way down and it caused some problems on really cold days.
So the air in the gravel gets cold enough to freeze down lower.
Yes. And so you've got a good dirt layer on there, and in a window well, like I said, some of our foundation companies, some of these guys had just been filling it up with gravel, and I thought that was a great idea too, because you want it to drain. Well, they said they've seen it, you risk a problem with frost being able to penetrate down deeper and get under the footings, actually.
Well, and cold air is going to drop into a well too. So
yes.
Mark, how much soil is necessary? I guess it depends on how cold it gets in the wintertime where you're at, but like 6 inches or like a foot or more than that?
Our frost depth here, they consider it 42 inches. And I don't know that really we ever see it go to 42 inches, because 42 inches has got a safety factor in there. And I always ask the engineers that I'm dealing with, what's your safety factor? And I think in a rare occurrence, we've seen frost at 36 inches, which is not all that much of a safety factor, but that's very rare and probably has happened once in the last 40 years.
Well, if you got a frost depth at 48, I would think that it would be extremely rare that it would be at 3 feet, and it's
Yeah.
a logarithmic from there. So
Yes.
maybe every 200 years or whatever, it would be extreme unlikely.
Right.
Yeah.
Yes.
Ours here is only 18 inches, and we never see it freeze even that half that deep here.
Yes.
So, at any rate, so I've got a little. We'll have our heat in here, and the way this works is if you're heating in a building, you're always going to have some amount of stratification. If you've got stratification, you've got convective loops. So, got heat is going up, and then it's going to fall down the exterior walls, and just continue these convective loops all the time. The more if you open windows, it changes it, different things, doors and whatnot. But basically, it's trying to simplify the idea of how this works. And then with if you got a crawl space, you want to think of that as just a short basement. Not, it shouldn't be treated any differently, and there's no reason to see it any differently in terms of those convective loops and how the constant ground temperature can still help you. If you've got a crawl space, it's going to be below the frost level for your area. It's why they have lots of basements in really cold areas, because of they're trying to get below frost. And of course, per IRC, you're going to have a sump pump in that if it's a crawl space. These are sealed crawl spaces, non-vented crawl spaces. Don't want any vented crawl spaces on my planet. It's just the way it is. Let's see. Yeah. So then, if we want to talk about cooling, I'll put my iceberg in here, and we can. These are going to convective loops are going to go the other way. So it's all the same principles, just whether it's a crawl space or a basement. The idea of these is there is no infiltration. That you can't think of these houses as like your typical leaky house that they're all going to be below 1 ACH 50, as opposed to I mean, most of Washington State houses, new construction, we didn't even have to get on board with 3 ACH 50 till this year. We've been at 5 ACH 50. You should be able to build a house to 1 ACH 50 without even thinking about it. If you use cellulose fiber insulation, if you use some of the techniques we'll talk about, how these houses worked was because there's very little thermal bridging through the walls or anywhere. Using an insulation type that's good at air sealing and whatnot. All right, so there I am, and why I have no back today or shoulders. We didn't have bobcats back then. You got the stone dumped in here, and you shoveled it all level by hand. It's just what you did. Today, there'd be a lot of whining, wouldn't there? But this stone is number one pea gravel. It's one. It's a foot. It would get spread out in here, a foot thick, and that's your basic drainage plane of the entire building. It's all about drainage, and if we did this with concrete foundations, we wouldn't have water issues with them either. This is 1983 now. So this is it was an octagon shaped house. These were 12-foot panels, 4 feet below the floor, 8 feet above. So that's just basic construction of that. We'll zip through that. This is this was the first house. I can't remember. Yeah, no, this is the second house I used truss studs in, but these were built on site truss type studs that they're a 2x4 ripped in half, and so you got a 2x2, a little bit more than a 2x2. I think if you rip a 2x4 in half, it's 1.75 by 1.5 inches, something like that. And
That was a lot of work, Charlie, to
I
build
know,
all.
but I could build one, cutting it all up, cut this webbing for them and nailing them all together. I could build one for the cost of a 2x6.
Wow.
So now I've got a 10-inch thick wall, and honestly, it wouldn't make much difference if it's a 2x10 or a 2x12 wall. The cost isn't going to change that much in terms of what it would take. I wish that I had gone to 2x12, but there were a lot of arguments that you reached a point where insulation stops paying for itself.
Mhm.
I have lots of skepticism about that. I think that yeah, what's the term for that? Can anybody come up with?
Rate of return, something.
Yeah.
Diminishing rate of return, maybe.
Yeah, and where you really see that functional is in remodels, where you want to put an addition on the house. It doesn't make any sense to put 12-inch thick walls on the addition that's open to a house that's 2x4 walls that you can't improve the R value of.
Mhm.
That's just not going to ever pencil out. But in a brand new construction where it doesn't matter whether the difference in cost between going from 2x6 to 2x12 with a truss type stud, the cost of materials is insignificant. So why over the course of the life of the house, not 10 years, that's where you get into trouble, is people want everything to pay for itself in 10 years. Well, we got to stop thinking like that about houses. We'll never get ourselves out of the dark ages as long as we only limit ourselves to 10 years.
Mm.
So I consider it if it will pay for itself over the life of the house, it's worth it.
Mhm.
Because you're not the only owner. It's the next owner that's going to benefit, and the next owner that's going to benefit. So it's a little bit different way of thinking about the economics of it. As far as the insulation goes, before you put the drywall on, you would drill all these holes in each bay, so that after you put the drywall on, you will know every place that has to have insulation blown in. Like even these bottom ones here, you would just drill one hole out. The headers the same way. Drill those on the other. Drill those from the outside, but
Hey, Charlie, on your rate of return on insulation, we've done some of that thinking about it. And, if you have, and if let's say it takes 18 inches to get what, an R49, right? Or so, whatever. Well, to decrease that, to decrease that loss by half, you've got to double the insulation. So you get to a certain level where it really is hard to get any further gain. Let's just say we put 50 inches in there. Well, adding another 2 doesn't do much. In order to see any appreciable loss, you have to put another 50 in, and now you've halved it, and you only halved it. By adding 50 more inches, you doubled the insulation, and you only halved what you got on the first 50. So there's your diminishing returns, and I'm sure you had a lot of those questions, and
lots of them.
10 inches is good. 12 would be better, but from 10 to 12 is not that big of a difference.
No, it's just a case of in new construction, why not do it while you can?
I agree. Yes.
You know, that's what you run into. You reach a point where like going to 16-inch sidewalls gets problematic because then you're increasing all your finish materials and whatnot around windows, and that becomes a factor that you have to think about as well. But over the life of the house, again, I don't think it matters. What I have a problem with is why do we only insulate our hot water pipes to R3? Those pipes got to be 120 degrees. And our house, we keep at 68 and we have to have our 19 in the sidewalls. Why pipes and heating ductwork? I think that they could benefit from more insulation typically, unless obviously if they're all inside the envelope, it doesn't matter that much. So all the headers were insulated. We talked about that. These are some of the zigzags we're cutting out of. There's 4 sheets of this is ACX plywood. It means there's no voids anywhere in it. So this was kind of, I priced it out the other day. This stuff is pretty expensive right now. But so is everything. So I tried to look at my cost to build these today is still way cheaper than this other idea I have of using TJIs and drilling a bunch of holes in them. Those would make good studs, but they're still going to be 3 times as expensive as building these. I looked at the dowel studs too, and they can't get to 2x12 without. I think he said they're making 2x8s now, but we'll talk about that in a minute. But this is my octagon house with all the snow on the roof and the appropriate icicles.
Not a single icicle on that house.
No, doesn't have them. And that was our discussion about this roof. Had a 3-tab shingle that lasted 30 years, and that plywood looks like the day I put it on there.
And can I add, you mentioned too, you didn't have any underlayment
right
underneath those shingles, right?
That's right. No underlayment at all.
Why did you decide to leave that out?
It was an idea going around at the time that it just wasn't necessary. I mean, by the time you punch it full of holes with nails and staples and everything, it was considered, as an old builder in those days, felt paper was something you put on the roof to protect it until you could get around to putting the shingles on. Yeah. It served no other purpose.
Yeah.
So
it still really doesn't. And the new felt paper, that is out of the plastic, is a new condensation point.
Yeah,
I think we talked about that last time, and it really condenses moisture on it, as as the ridge vent. The ridge vent just condenses real good too.
Please don't think that the code is a done deal. It's going to change again. I could easily see felt paper becoming optional. Really, I could see. I'd like to see thermal pane windows go away. We can talk about that some too. I think that you look at thermal pane windows, I think they're never going to pay for themselves. How often do you see failed seals at 10, 12 years or even earlier? Especially if they have that new type of channel with the exposed desiccant. See the desiccant fall out and drip out, and those have been known to fail in 6, 7 years on the south side of a building, and that glass is not recyclable. I would rather see old style single pane windows with nice tight storm windows, frankly, than those. But you can't put expensive gases in them that dissipate in a very short time as well. It's kind of an interesting conundrum, this business of not only saving energy, but when these things get codified, you can't adjust for it easily. Like how do you deal with the fact that thermal pane windows will never pay for themselves, but it's in the code that you have to do them? What if we as a society decided we don't want to do that? Well, then you got to undo the codes, and the codes of constantly being, especially electrical code, there's always things that are being changed and undone and redone and rethought, and unintended consequences, it's called, right?
Mm-hmm.
So this is the foundation of that octagon house, and this was 30 years after I built it, and I wanted to see if there were any signs of condensation on the plywood. This is on the south side of the house where the plywood is only maybe, this might be at most 5 feet below grade, 4 feet below grade. So it seems to behaving itself pretty well. This is the attic of that house. Again, looks pretty good for a house that I totally screwed up the ventilation on. I had no clue about ventilation. I didn't know any of that stuff back then. I got really lucky in lots of ways. This house had 15% up high and 85% down low in terms of intake to exhaust. Anybody ever hear of that being okay? But how would you fix this roof? You're an
Well,
inspector. You go into this attic and you see this. Are you going to call for adjustments to the ventilation on it? Yeah, I mean, how can you? And yet it's wrong, right? It's wrong per current standards. Well, why are the current standards wrong then? They obviously can't be correct if this is succeeding in an area really prone to mold and all kinds of nasty attic conditions. Well, because it's got R60 cellulose in the lid. It's totally sealed. There's no moisture from the interior getting in there. The cold winters are 5-10% moisture content. There's just no opportunity for moisture to be an issue in this attic. Not even enough rats to pee in the insulation or anything. So that's probably the most moisture in this attic. Is there were some, they had some mice that got into it somehow. But at any rate, so this picture was from 2016. I built it in 83. So you can see it's behaved itself pretty well. Now we're into another house. Again, there's those truss studs. These were 10-inch truss studs. Talk about my pet pipe clamps. I couldn't build houses without pipe clamps. These are some of the plans for that house, and you notice that the corners are all hollow. So the insulation goes through the studs and around the corners. If you've got a partition, it looks like that. So it doesn't have any wood that goes all the way through the wall. It's just some of the extent that I went to break that thermal bridging. In a 2x4 house, it's about 24% of the wall is solid R3 or 4.
Mm-hmm.
You get to 2x6, it's still only R6 for, generally you're at 24-inch centers by then, so it's maybe only 15% of the wall that is R6. But the idea with these super insulated houses is minimizing that as much as you possibly can. So when you have a header, I think there's a header right here. The jacks that support the window sills and the or jacks that support the header, and then the what do you call the ones that support the sill? They're cripples. Cripples, yeah. Those are all 1x instead of 2x. So again, you're reducing that total amount of wood in the wall. And once you go to 2x6, past 2x6, a 1x8 or 1x10 rather has as much surface area as a 2x4 easily. Then we got this is a header down here. So you take a 2x10 or a 1x10 for that matter, and rip enough off so that it fits in the wall thickness. If it's a long header, like over an 8-foot or 6-foot doorway, you'd put a zigzag inside the header, and then you're insulating in between each triangle. Create the as much insulation in the wall as possible. We're going to talk about an alternative to that when I get into the section on what I would do today if I was going to do this type of building.
Charlie, quick question. Was that header like a piñata? Was it stuffed full of cellulose? What did you use?
Cellulose,
inside
yeah,
it?
blown cellulose. Yeah.
So you drilled a hole and blew it in.
Yeah, you drill a all the insulation holes were 2 1/8. That's the standard size for blowing in cellulose. Drill a 2 1/8 inch hole right here and one right here, and you just blow them solid. Yeah. So here we've got a typical section view of a wall, and you can see this is a vaulted truss or a
It's like an energy heel almost.
yeah, they all have this. All my houses had raised heel trusses. Now it's called advanced framing. Finally, but it was common knowledge back early 80s. The weakest point in this whole assembly is this solid top 2x10. But the doubler on top of it didn't have to be solid, so then you could have insulation in between them, and it broke that thermal bridging. But this is I still consider this a weak point, and I'll show you how I would solve that today. It's just a floor plan of the house that we're looking at. That wall we saw the truss studs in was this wall down here. And there's that same house, and you can see how the tarred foundation, when you got to a point that was going to be above grade, you changed away from pressure treated. You can see this is all pressure treated up here. You can see the color difference. It's kind of cool wood foundation because you could your siding could slope with the grade of the land instead of being stepped or having to inset. You see, sometimes people will inset into the foundation, so you have a nailer to run siding down at an angle. But wood foundation makes that a lot easier. There's the perimeter drain coming out. We'll talk about how that works. The perimeter drain runs around the interior of the foundation, not the exterior. You've got 12 inches of pea gravel that fills all the way out to your excavation line. And then you put geofabric on top of that stone outside. And you're protecting that drain from ever clogging or ever being an issue by having it on the inside of the foundation. This is another house. This is in 1987, and the orientation of all these houses was not magnetic north. Like this is the south face of the house. You see it's cocked a little bit toward the west in order to, in upstate New York and most parts of the country, really, even here I see it, where it's often foggy in the morning, especially in the winter. You get and you can see it here. We're here at 8 o'clock in the morning, getting ready to start work, and see how it's all foggy in here. The sun isn't going to hit this site for some amount of time later, and so the house is oriented to favor that. So it's 10 degrees east of magnetic was what I used, but just something. Here's the house again, magnetic north. It's a little bit off.
Was that something you learned about through other research at the time, or this is something you came to your own conclusion on?
Yeah, that I came to my own conclusion on, just observing how long it took for it to get sunny in the morning.
Wow. You paid so much attention to detail, Charlie.
Yeah. The primary entry, it was important to me to have an airlock entry, and it could be, you could call it a mud room or whatever, but why not? You have a double door where you soften that blow of 25 below zero coming into the house all the time by having an airlock to avoid that. This was a big fitch plate beam in that house. It's 30 half-inch steel plate, 32 feet long, 30 inches tall, and I had micro lambs on both sides. All this was bolted together, and then we jacked it up, built it in place, and then jacked it up 6 inches at a time. Just a couple of 5-ton jacks, and you jack one end up and put a block in, and then put a solid piece of wood against the blocks, or two of them actually. But so I never had more than one employee typically, and the two of us would do this work right through from foundation to framing, roofing, drywall, plumbing, electrical. We did all that stuff. That's just the way. It was easy to organize. You didn't have to wait for plumbers or wait for electricians.
I
Sometimes
realized, Charlie, sorry to interrupt, but we never talked about that in the first class, that I assumed you had a crew of people you worked with. You're saying that there was usually just you and one other person, and you built the entire house yourself.
Yeah.
Oh,
sometimes if we had, we would bring in one other guy or something. You'll see, I think there's a picture of the guys on this roof where there's two of them up there, and I'd hire guys for a day or whatever. But generally speaking, me and John Boy Walton did pretty much everything on these houses. Sometimes the owners would help. Lots of times, actually, the owners would be in on it too. So that I can't discount that, because they were a huge help lots of times.
Cool. Yeah. Wow.
There's that beam right here. And the roof in this particular house, these are, I think they were 21-inch truss joists used as the roof rafters. And then we put 1x2s in between under the sheathing, and added Celotex board, which is just it's the cheapest thing I could buy to do that with. And it's also 1/2 inch of insulation as well. So we would, I use that. And so we ended up with a space for 18 inches of blown cellulose. There's pretending to cover it with more Celotex. And the roof was like this. This is on the top side of that plywood. And so let me back up one. So this vented space you see right here ties into the vertical wall of the clear story. And so you vent this roof and up and into the attic space of this upper roof and then out.
So the air went across. Okay, that's helpful to see. Why did you vent the air up the vertical wall, Charlie?
Well, because we get a lot of snow, so the roof, this upper roof was going to just pile snow on this lower roof. That vent would be covered all the time. If you did a vent right here, is that
Okay.
what you're thinking?
Well, yeah, I was just wondering, because usually, I mean, what you'll see is if you got an upper and a lower roof, is that each roof is treated separately, and they each have their own intakes at the eave and their own exhausts at the peak. So I was wondering why you decided to connect them, but I guess that makes sense if you didn't want to put some sort of roof vent
Yeah,
on the lower roof.
I just didn't want a roof vent on this one because of it. If it faced west or faced north, I might, but because this is exactly where all the snow from the north is going to dump on that south roof.
That makes sense.
Yeah, that
Yep.
was the reason.
Yeah.
I would discourage clear stories in the future anyway. But you know, we'll talk about houses, and in a way, it gets to the argument of how, okay, so we're going to make it so efficient, I can afford to have more volume. Not anymore. Not anymore in my thinking. It's like you want to reduce volume wherever possible. Don't do scissor trusses, small vaulted ceilings don't matter much up to say you want to go from 8 to 10-foot vaulted, but when you've got 2-story vaults, that's counter and everything green, in my opinion. So here we are. We had a 16-foot jig so that I could make truss studs 16 feet long or 8 feet long, whichever I needed. This house had some 16-footers that I needed for a stairwell. So, and that's why in this next picture you see, this is very rare to ever see walls that aren't sheathed before I tilt them up. We always sheathed all our walls before we tilted them up. It's like, it's too hard to do when they're tilted up without the sheathing. How do you get up? You got to balance on boards outside and ladders and everything else. So we completely.
Charlie, the longest wall I ever stood sheathed with the windows in it was 220 feet long.
Yeah, that's a long one.
And we
You
had
did it
all these
all by
jacks.
yourself, Mark? Wow.
Well,
Yeah,
yeah. We'll go there. Yeah.
well, you can do it with
Did-
kicks.
did
Super,
you see
we
my
knew you're
cape?
superhuman, just not
Did you see
to
my
that
cape?
extreme.
It's tucked
Yeah.
in. Yeah. No, we had the pump jack, and it was quite the deal.
Yeah, there's all kinds of tricks to do that with.
Yes.
And this house had a 32-foot wall we had to tilt up. 2 of them, actually, one upstairs and one down. But yeah, you can do it. Like this whole wall here was all sheathed and built and tilted up. But it wasn't hard. Just 2 of us did it. But I think this is the one that 30 years after construction, the house tested at under 1 ACH 50 twice. I think we talked about that. So given what I know today and how I was able to achieve that when I didn't have a clue, it's ludicrous when builders tell me it's too much of a struggle to get to 3 ACH 50. It's going to cost me too much money. It's too hard. I don't have any sympathy for them at all.
That's pretty amazing. That's a very airtight house.
Yeah. It's HRV. Okay, so now we're going to get into a little side trip into permanent wood foundations, and Mark was involved with this one. It was a client that called me. They were having moisture issues in their crawl space, and you may remember this better than me. So chip in if you think of something else, Mark. But what had happened was I went and looked at it, and well, let's get there first in the pictures. Permanent wood foundations. This is 76 to 86. This is the foundation handbook guide for how to build a wood foundation, put out by Weyerhaeuser. And this is their manual. I still have several copies of this. But it's full of all kinds of detailed drawings about how to do footings and different kinds of walls that are backfilled or not backfilled. And so it's a really, really valuable guide for how to build the wood foundations. So this foundation, this is what I saw when I got there. And see that they've got poly on the ground, and they've got poly up over the foundation and up over the insulation that's between the rim joists. And this is just fiberglass behind here. This is the outside. It should be covered. It isn't per the guide from Weyerhaeuser. It wasn't required to be, but I would highly recommend not leaving it exposed. It's not a problem with water. It's a problem with UV. So there was some UV damage to it. So I would want to see nice copper flashing or something like that around the perimeter. There are some other materials. You could do stucco. You could do the same thing they use on exposed ICF foundations, perhaps. I think that's a plastic. One I saw was plastic, different materials. I'd avoid aluminum is all.
We got a comment from Dusty saying wood foundations scare me as much as eaves installed in 1995. True that, Dusty.
Well, I hope I can. I hope you guys find some that were actually done right, because honestly, if they're not done right, they can be as bad as never as bad as a block foundation. Maybe you won't agree with me, but anybody ever seen problems with block foundations?
Oh, never. They just perform like you can't believe. Charlie, when I started, everything was block.
I know,
and then,
me too.
And I was in there. It was 1976, and I actually did some work with tending the block. And what a ridiculous deal. And then we had poured foundations, and those were pretty cool. They didn't have the brick pattern in them. They had a smooth pattern in them.
Mm-hmm.
And then they went to the brick pattern, and I thought, oh, those look nice. I'm back to where I really like a foundation that's got the plywood forms in it, and you see the wood grain in the forms.
Yeah.
And that looks pretty cool.
Yeah. And there are advantages and disadvantages to both approaches. I still today would not build a new house without a wood foundation. I wouldn't do it. I know I can do it right, and I know I can do it so that they will last forever. If they get wet, they're built wrong.
Yes, that's right. And if you're down there in Dusty Land, I'd be careful too.
But Dusty, you gotta like my sealed crawl spaces. This is easy to do with a wood foundation, and At any rate, let's so you can see a little bit of deterioration on this plywood. So I think it's probably a good idea that this all be covered. Um, see that deterioration? That stopped right at the dirt. You know, it's just too much south sun exposure, not rot, just mechanical damage.
And Charlie, is that the actual exterior wall sheeting or is that a cover over something?
Yeah, this is the actual.
Okay, because when
treated
I built my
plywood.
wood foundation, there's a layer of foam all the way around the outside over the top of the sheeting, over the top of the treated plywood. And then we put an additional layer of treated plywood from the ground up.
Yeah.
And
Cool.
it looks, it's starting to look like that. I built it
Yeah.
in 1989, 90, and
Yeah.
my son still owns it. So I get there every once in a while to look at it.
So you could flash it.
Yes,
Yeah, cover it with something.
You
but
know,
not aluminum. You
Yeah.
can't cover treated with aluminum.
No, that's what I
I would-
say. You really don't want to use aluminum.
No.
what do you do about termites? I mean, you don't have to worry about termites where you are, but I mean, I would think that would be a big problem if you're trying to do this in the South.
This is impervious to termites. Termites cannot eat this grade of pressure treated lumber. They
That's
will.
right.
If you see them in pressure treated lumber, they're in the core of a 6x6 that never got treated or something like that. But foundation grade pressure treated lumber is impervious to termites. Yeah.
That's right. It's a 0.60 treatment.
Yeah.
So and all 6x6s are 0.60 as well automatically, but they don't go all the way to the core.
And that's
And
why they
there's the
don't have
problem
an
when you
FDN
see 'em.
stamp on them.
Yes.
They have to have that FDN stamp. If you're inspecting these, you want to, if you can't, the problem with inspecting wood foundations is you got a basement, they're going to be covered with drywall. It's going to be really hard to know what you got. And you could do a borescope and check for fasteners. Maybe you might see but even the fasteners aren't going to show typically. Anyway, so in this picture, you can see this bluish green. That's where the wood is wet, and some of the copper naphthenate, copper salts are efflorescing out of the wood. So this is a sign that it's wet. How can you tell if it's wet?
You can't check it with a moisture meter.
Only relative, like all of this pressure treated lumber
Yes.
will read at least 32%. So it's going to be a positive reading. But if you stick it in this area that looks wet, it will peg out at 90% or 100%.
Yeah, you can take relative measurements, go
Yeah.
into a known dry area and check it and get some
Yeah.
good baseline readings.
But
Yeah,
don't
but
assume that
But
you
your
stick.
eyes and your brain tell you that that's wet.
Yeah,
You don't even need a
absolutely.
moisture meter.
And the efflorescence tells you it's wet.
Yes.
And probably
Okay.
your nose.
What's that?
And probably it smells too, musty.
It might, yeah. I tell you, not much grows on pressure treated lumber. It's you're not going to find mold growing on foundation grade pressure treated lumber. That might be a hint that they used materials that weren't. Maybe they used appearance grade pressure treated or something like that. That's just not treated to the same level. Here's a fastener that's sticking out. It's an exposed stainless steel fastener. So that's another hint that they at least used the correct materials. So you want to look for this FDN stamp on all the studs. You won't necessarily see an FDN stamp on the exterior plywood. You might, but as long as it says exterior grade pressure treated, it's probably the right stuff. And you can certainly tell there's that efflorescence again on the bottom of this. There's a obviously wet area and wet dirt against it. So it was kind of curious. So why is all this water condensing behind this insulation on this foundation? Well, it was originally designed as a heated crawl space. In other words, it communicated with the indoor space. So they took the furnace out of the crawl space and put in mini splits for the house. That's when their problems started. You can't do that with if you got a crawl space that's sealed, no vented. One guy told him that, well, you got to vent that crawl space. Well, I didn't want them to vent it. I would rather see them maintain it as a conditioned crawl space. Make it communicate with the indoor space. Yeah, it doesn't have a furnace down there to do it automatically, so do it intentionally in some other way. Because now, if what do you do? Think about how complicated it gets as soon as you decide to vent it. Then you got to insulate the entire floor system, and then you're cutting it off from that constant ground temperature. So all of these, to me, you know how often we recommend, who as inspectors recommends conditioned or sealed crawl spaces? I'm sure Dusty does, and if you've already got a sealed crawl space and then you're going to muck it up with ventilation, no, you're already halfway there. So that's kind of where they're at. They called me about 2 months ago, actually. I told them to call me back in a year. I wanted to see how it was performing. They had, do you remember what they did, Mark? Did they foam took the insulation out and foamed those walls, or I can't remember what they did.
Hey, do you recall the address of this place? I'll look it up.
Yeah, I don't even remember that.
Yeah.
I am excited about going back and looking at it because I know they I think they were going to run what do you call it with the mini split when a ducted? They're going to run a ducted unit off one of the mini splits so that they could condition that space.
Sure. Yeah. Yep.
And then put in a dehumidifier.
Yeah.
You don't. There's another thing that in the code that is. I think Dusty, you probably can answer this. Aren't you required when you put in a sealed crawl space, you have to put a dehumidifier in?
You've got 4 options. You can do dehumidification, supply air from your HVAC. Of course, well, yeah, there's something with a plenum. I've not done much research on that one.
Yeah.
But the code says there's 4 options for them.
Yeah. Well, I mean, I want like the mini basement theory. I want that thing treated. What would you do to a basement? You wouldn't. You don't need a dehumidifier in a basement, do you necessarily? I know some areas you do because they didn't.
We always recommend dehumidifiers in basements. The 4th options for that crawl space is exhaust air. They say exhaust it out.
That's right. That's right.
Yeah.
So you're constant under negative pressure. And honestly, I don't have a lot of heartburn with that approach. It is a mechanical device you got to maintain, and it's going to be running 24/7. But it doesn't cost anything to run that. 75 CFM fan, even if
No,
you're,
it's more about exhausting I mean, you're, like you said, your crawl space goes under negative pressure, so you're exhausting the conditioned air out. But
that's
the
right.
idea is you're moving it from the house to the crawl space as opposed to the crawl space air moving into the house.
That's right. And I don't, with this type of system I'm talking about, where you've got a totally sealed system, you got double poly under a concrete slab, you're not, radon, soil gases are just plain not an issue in these houses. So whether you're pulling air, if you're cycling air from the house to the crawl space and back into the house, it's just not going to matter. There's just there's no time to build up anything. So it's just whatever your air quality is indoors, it's going to be the same as your air quality in the crawl space. And it works because Syracuse University tested a lot of my houses for radon, and they all were perfectly fine. So
Well, you're
that's
exhausting that radon out up your edge of your wall, and you have that little soil cap there, and it's exhausting. I told you last time when I was doing basement finishes, if the basement was mildly elevated in humidity, I would have my clients test it for radon because I knew it was going to be high, and I
yeah.
knew when they put an active radon vent, it would dry the basement down. But on a wood foundation, it's got so much gravel underneath it, you would not get a draw on your active radon vent because you're putting it in a foot of gravel and it's up the side.
Yeah.
You just wouldn't get a draw.
It'd be all your downspouts could work as radon chimneys for that matter. It's just not an issue with a wood foundation, and the drainage system again is key to its success that
Yes.
way.
It's not an issue if the wood foundation is built correctly.
That's right.
And so Charlie, you did a lot of studying and I did it too, and I'll bet you and I build it exactly the same way with maybe some minor differences, but nothing big.
Yeah.
Yeah.
All right, so let's keep going here. So this is a mock-up. I used this this drawing right from the Weyerhaeuser manual to tell them the kinds of things that they could do to improve their crawl space. They didn't have a slab down here. So, but otherwise, they could put 6 mil poly on all of the tar, dig it out, tar the foundation, put 6 mil poly on it, put a drainage plane over that. That's another really cool thing, that there were none of these fancy drainage planes like we have today when I built my houses. I love that stuff. That's just so awesome. So yeah, install that. I recommended that it be that it continue to be a plenum as opposed to vented to the exterior. There's no slab. Drainage plane recommended over the vapor barrier. Flashing here to cover that exposed wood on the outside. Not something that is a part of any of these recommended installation instructions from Weyerhaeuser, but I guarantee you they would have it there today to redo this book. All right. So there's a 4-inch concrete slab against it works as a kicker to support that, keep that bottom plate from kicking in. There's other ways to do it. You can even build a pressure treated wood floor to do that. I always did the slabs. I wanted that slab in contact with that 50-degree ground temperature. This is my heat and cool sink for the house, really. There's a FDN stamp again. I think I've got this picture in here twice.
Is that half inch on the exterior?
half or 5/8, three
Yeah.
quarters sometimes.
Yeah,
A
we
lot
use
of that depends
3/4.
on how
Yeah.
how big the backfill was,
Sure.
how high the backfill was. So where would I take building framing now, 30 years later? So I had this idea and I played around with this with Donnie Hester a bit on a house he was thinking about building, and cutting a bunch of holes in a TJI and using those. But these are pricey
Yeah.
in terms of not for what they do for a floor joist. They aren't pricey, but they're pricey to make a stud out of.
Hmm.
I really like this version. I really like these a lot. It's a different idea from the dowel approach, but these you can get in different widths, like 14-inch, 12-inch, 10-inch. And minimal amounts of wood again, kind of like my truss studs.
That's a floor joist, isn't it?
Yeah,
Boy,
yeah,
and then that solid piece is so you can trim it and cut it for length. So
that's
you
right.
order them reasonably the right size, and then you have a little bit of adjustment. Yeah.
That's right. Yeah.
Yep.
And there's the dowel approach. If you want to, I was listening to him talk about what if I wanted a 12-inch wall, and he said, well, you'd have to figure out some way of screwing another wood member onto it. So again, then you're increasing that amount of wood that's in the wall. So I don't think you can beat my truss stud, frankly. But at any rate. So here's a typical wall attic detail, and you can see what I've done here is I've got the raised heel, but then I got a dropped heel to bury this top plate.
Nice.
So that's
Awesome, Charlie.
that's what I would do with it today. So that see, we're getting rid of that mess, burying
Yeah.
it in insulation at least. There's the raised heel, drop heel.
Charlie, why do you have 2 layers of rock? We'll talk to that.
Yeah, I built several houses where I doubled the drywall, just as a cheap way to put thermal mass in the house.
Okay.
Yeah.
And it's, the airtight drywall approach is a good approach, and that would help it even more.
Yeah.
Get rid of these plastic vapor barriers. They're
Yes.
hurting things.
I never
Yes.
used a plastic vapor barrier. All the drywall is continuous glued,
Yep.
all edges, all studs, and the double layer, like I said, for the thermal mass. But drywall makes a great air barrier, and with walls that are 48 cellulose, you're just not going to have an air leakage.
Yeah, and it's
And
got a
it's
slight permeability too, so it can dry. It actually can almost dry to the interior, where you lose that when you put a vapor barrier on. And now with our smart vapor barriers, you don't need them.
it will dry to the interior or exterior depending
Yes.
on where your
Yeah.
season is. So
Yeah, and it depends on what paint you put on it too, because that can slow down things.
yeah. There's only certain climates, like Syracuse, we used a painted vapor barrier on all the insulated exterior walls, on the envelope
Sure.
walls. But most of the country doesn't need vapor barriers.
No.
Uh,
Now you
so-
need to be airtight. You need to seal around your boxes. You need a gasket at the top. I did air testing on some houses this winter, and we had frosted outlets. I did some smoke testing from the outside and had my blower door going, and it really irritates people when I pull all that smoke to the interior and show them how leaky their house really is. And even though it had the right ACH 50, I don't care about ACH 50. When you can have a point, let's say you have a 1 ACH 50. Well, find out where it's leaking, and it might all be leaking in the wrong spots.
one place.
And there's a new thing. I was just out at Joe's deal for summer camp, and he was talking to me about There's a new way to look at this. Take your square footage of your inside wall and then decide how much air leakage you have with the mass instead of just saying an ACH 50, you know.
Yeah,
There's
yeah.
a different way, your exposure.
Well, it's the same. I mean, R value doesn't mean much either, right?
No.
It's the cumulative R value along with the air leakage of the whole assembly that's really what's important.
Yeah.
I
boy,
like a
if
blower, with a blower door where they take the door off, front door off and put their blower door in, and then they
Yeah.
put the door back on without any weather stripping.
Yeah.
You know, what's your air leakage then?
Yeah. Yeah.
So there's lots of places to screw up.
Yeah, you fill the house with smoke and then you pressurize it the opposite way.
Mm-hmm.
And you make sure that you call the fire department because the neighbor is definitely going to call and say the house is on fire.
What do you think about this AeroSeal stuff where they fill up the house with this sealant and
Mhm.
it pressurize it then and it fills all the holes and gaps and
You
We
mean for
have
duct
one going.
sealing?
Yeah.
yeah.
Well, they do it in the
but
house
it's for the whole
instead,
house.
Tessa. They do it in the
Oh,
house.
okay.
And we've got one going up, 40 miles from me right now that I'm kind of looking at. And it is a monster. And they're going to do that and test it. And the windows, they're European windows,
Again, you say
$200,000,
monster, I immediately react. It's like,
$200,000 worth of windows.
yeah,
Yeah.
not green by definition.
Yeah.
Let's just hope that house has a robust ventilation system that is well maintained by the homeowners.
yeah,
Yeah, because ERVs and HRVs are important, but they are another thing that's got to be maintained.
Yeah, and most people don't maintain them well. I've got 2 under consult right now that have severe moisture problems, and they have an HRV and they don't maintain it, and
Yeah.
it's all foamed on the inside, and they've got a big mold problem up in the attic, and it should be a conditioned attic, and people don't realize this. Here, I'll ask you a question: What is heavier, dry air or wet air? It's counterintuitive. It's counterintuitive.
What's heavier? Oh,
What is heavier?
is it drier because it's colder?
It is, and all the humidity pushes to the attic. All the humidity pushes to the attic. The wet air
Warm air
pushes to the
rises.
attic.
That's
It
why you
rises.
don't.
interesting. Yeah.
By the way, warm air does not rise. Did you
It's
know that?
less dense, so the
Yeah,
cold air pushes it up.
That's exactly right. It floats on cold air. So
That's
just
a
a little
little.
bit of something to get everybody's head screwed
Well,
up.
that's a little bit like air isn't sucked into soffit vents; it pushes into soffit vents.
Yeah.
Oh,
Yep.
So is anybody's energy code requiring a raised heel truss anywhere?
Mine.
The
No,
energy code
I
of
mean,
Charlie?
but we're going to talk about raised heel trusses here in depth in a little bit here because I think they're super important. Should absolutely be required by code.
It just floors me that it's not an energy code thing. I just can't. It doesn't make any sense to me.
It might
Yeah,
be.
Especially in
It
all
might
those
be coming up.
inhospitable climates, where it's cold.
You're going to like my alternative header design too. Yeah. So this is typically our header with the insulation in it. But why do we locate it here? Why don't we put it here? Put an LVL all the way around where your raised heel runs into, and don't have any headers below the top plate. There's
Mm,
no why. There's no need to have any headers below the top plate. Just run LVL all the way around the building.
cool.
I
idea.
got this idea because this is how I used to do second story additions to avoid having to take out any ceilings. We just run an LVL all the way around, put TGIs between them, and just bury that old floor ceiling system without having to touch any of the wiring or anything else that's in there. So it's I think it'd be, and is it easier to run LVL around there or build a whole bunch of headers?
Yeah.
Yeah, so that's a big thing that I would do different. So the TGIs are obviously going to be more expensive way to do this stud, but it's going to be easier on the carpenter because he doesn't have to have that whole process ahead of him of building the truss type studs that I make. But that other type, I think, would be doable, and they're much cheaper than TGIs. So they all wood when I showed. All right, what do we got here? So there's our raised heel truss. Why should raised heel trusses be required? Well, let's look at this. So here's a typical truss coming down, sitting on the top plate, and you can see that this is a real weak point here. If this isn't sealed, it's bad enough that the insulation is nowheres near R38, R48, whatever is required in your area. It'd be better if that area was sealed, but it rarely is. You know anybody that seals that connection? So in the wintertime, you can see the air comes in and it goes through the insulation, and you end up with heat. Heat goes to cold, right? So we lose heat in the winter to that cold stream going through the insulation.
And it increases your ice damming as well.
Sure, absolutely. So in the summertime, the opposite happens. We've got heat pushing, hot air pushing into the attic through the insulation, and we increase our cooling. So this guy, Steve Howard, sent me a picture. He's on the East Coast somewhere of how he seals that area. He's got some baffles, and he spray foams that area to seal that. That's as good as you're going to get in that type of truss. You just can't get it any better. This is 18 inches of white fluffy with that kind of a non-raised heel truss, and you can see there's the thermal in the winter, thermal in the summer. So both, it's a good visual, I think, to give you an idea of how important a raised heel truss is. It's a huge area that's too hot or too cold all the time.
It was built to code, Charlie.
I know. So vents should be outboard. Don't ever put the vents here because the sun hitting this wall can get pushed into that space. It doesn't matter so much with this much insulation, but if you're looking to not melt snow on your roof, that's something that you can look at.
I was going to add really quick, Charlie. In inhospitable Minnesota
Yes.
climate, there's a ton of houses when I worked for an insulation company years ago that were like, 1950s, 60s ramblers that had like a pretty low pitch roof, like a 412 slope, and they had ice dam problems. And so they would, we would do all the air sealing, all the insulation in the accessible attic space. And we found that because we couldn't access the exterior top plates and really air seal in that location and get adequate insulation, it didn't matter how much insulation we put in the rest of the attic, they were still going to have enough heat loss at the exterior wall top to melt snow and still have ice dams.
Absolutely.
So we would guarantee people that unless, we would sometimes remove a strip of the roof decking if the roof needed to be replaced at the same time, and do closed cell spray foam over that exterior wall top. But that was the only way to seal it, to air seal it. And you still couldn't get enough R value there if it didn't, with the 1950s, 60s framing, like 2x4 birdmouth rafter.
My my nephew's house in Connecticut had a vaulted ceiling, 2x10s, and he spray foamed that entire space with spray foam. But what's the R value of the 2x10?
Yeah, 10.
The cumulative
Yeah.
R value of those was enough to, he had ice dams with that.
Yeah.
You know, you
Interesting.
have to break it, and I there's ways to do it, and it's easy to do. You just got to do it.
Mhm.
But at any rate,
Yep.
this is just a flat roof. Same idea. This vent the flat roof. Typical wall floor wood foundation detail. So here's the wood foundation. You got foam on the outside, protected. And we want to get that up to R48. You can see there's a drainage plane on the plywood in here. R48 everywhere. And I'm showing TGI in here, but I wouldn't. Some kind of through the stud insulation anyway. There's an idea for this plate here. You could use a TGI or not a TGI, use a LVL or something like that and drill it full of holes. But again, that's labor intensive, right?
Mhm.
You could also just do a double plate like this, some configuration, something that would still allow your hold down bolt. Nice to have these all bolted through to each other. Concrete foundation, to get to the same R value, you gotta, gets a little more complicated and more expensive, right? Because you've got to build another wall inside, but it's all doable. And otherwise it's all pretty much the same. The footings for you can do an all weather wood foundation. You can be just on a wood plate, like a 2x8, maybe on a 2x12 plate, concrete vapor
Dusty,
barrier
that's the
under.
footing. That's the footing for a wood foundation.
Yeah,
I just
amazing.
want
Huh?
to say that to you.
It
Amazing.
was
Huh?
kind of blowing my mind looking at it. My brain's racking over here.
But you
Yeah.
know, it never gets wet, or maybe damp, but it's fine. It's designed that way. And this system, where do you think this system was developed for use in? Weyerhaeuser came up with all of this, and they built thousands of these foundations all over the country, but it was specifically designed for Alaska.
Hmm.
Because it could deal with the permafrost that no concrete foundation can.
Hmm.
It's flexible, resilient. So,
How would it do in like all those expansive soil kind of places?
well, there was a picture of one that was built near a river, and the river washed out under it, and it just stuck up in the air. it didn't do anything. It acts as a beam. So they're pretty tough, pretty strong.
Mhm.
Obviously, it has limits, but
Mhm.
Before we go away from it, guys, I want you to take special note to the little rat
Yeah.
that he has drawn in the outer tube.
Your
I love,
graphics are great, Charlie.
I love my rats.
Yeah.
Lots of rat stories as a builder.
Mhm.
Yeah.
So there's our picture of the concrete slab again. Now, if you got a concrete footing instead of, it would look like that, but then you've got to connect that drain. You're going to have a drain inside and outside with that likely, which I still want that drain on the inside. But
I want a sump pump on the outside and the inside, and I don't want them connected. I hate the fact that we bring all our water from the outside to the inside and then expect that little sump pump to take care of it.
yeah, on my
And
planet, we don't
yeah.
allow houses to be built where sump pumps are necessary.
Yeah. You're all slab on grade, huh?
Yeah. Well, I mean, slab on grade can work. It's harder though. You need to get if you got a slab on grade house, how are you going to
That's funny, Tesla.
keep that house in contact with constant ground temperature? So you got to have some kind of a footing down around the perimeter on a
Hey,
slab.
Charlie, I just want to take a note here. Dusty and Tessa are ganging up on us in the
Yeah.
chats.
I know. Oh, in the chat?
Yeah.
You know
Yeah.
what, Charlie? If you built my house with a permanent wood foundation, I would trust it. But I have yet to see one that has not failed. Every single wood foundation I've run across in
Come down to
Minnesota.
Des Moines, come
has
down to Altoona,
failed.
and I'll show you one.
Yeah. Okay, I guess I mean there's so many variables that if one thing goes wrong or it's not maintained properly or the water management's not good, like it seems like
Yeah,
a pretty
man.
fragile system.
How many concrete foundations have you seen that have failed?
Structurally, not that many. It depends on the location.
But have you seen them wood foundations structurally fail?
Well, they're wet and they're bowing, which
Oh
in my
boy.
mind is
Well, that's built wrong. That's
Somebody
all I
did
can
it
say.
wrong.
But you
Somebody
know,
did it wrong.
I know a guy that built a lot of wood foundations in Minnesota, and he tells me that he's seen them and they look fine still. So you just may have an area
Mhm.
that the builders in your area are
I also
didn't
wonder
get
when a
right.
contractor says that, hey, I've been doing it this way for decades and I've never had any callbacks. It's like, okay, well, that doesn't necessarily mean there hasn't been problems with what you've been doing.
No, absolutely. And that's why I really wanted to go visit mine after 30 years. And
Yeah.
I personally visited 5 of them, and none of them had issues.
Yeah, that's why I'm curious. That's why you're blowing our minds, Charlie.
Yeah,
Yeah.
I think for me, you would have to convince me on price. I mean, you'd have to like get the build cost down.
Oh
Like,
God, the build cost is astronomically cheaper than concrete. poured
yeah, I mean
concrete.
that would be the thing. I mean, otherwise like it's hard. I'm kind of with Tessa. I mean, part of it is I've seen so many poured foundations, and I haven't seen many fail. And when I see a wood one, I feel frightened.
Yeah. Well,
You know, like all
I-
this wood in the ground.
Yes.
Hey, Charlie,
I've looked at.
there's another person here in our room that is against us now too.
I know. We'll ban them next time. You know, I've looked at probably a dozen wood foundations in Washington State because they find that I know something about them, and so I get called to go look at them. And I've yet to see any failure with any of them. And the one that had this problem that we just talked about, that wasn't a problem with the foundation. That was a problem of changing the heating system and you changed the whole system. You screwed it up. Yeah, you're going to have problems, but that moisture that was condensing on the wood in the crawl space wasn't creating a problem. It's the moisture you don't want there, but it's not on the surface. It could even grow mold. So that wasn't an issue. So it's case by case, I guess.
Yeah. Yeah. This one that I built was 33 going 34 years ago now. And no problems. My son owns it now. And it's a rental for him, but I still go out and check it out. And something else I just thought about. That's the original sump pump motor in there. And I better be getting it changed.
Yeah.
I've never seen a wood foundation. I have yet to stumble across one of these, so I still find the concept very spooky.
Oh no. 1, 2, 3,
Yeah.
4,
Yeah.
5. Anybody else want
I've
to
only seen 2 of them in all the years. I've only seen 2 wood foundations.
Yeah.
I
Well-
must say, you made me feel much better about them, Charlie. I mean, when I first saw one, I was just like, this can't be good, but I don't know. I've probably seen 5 or something, and they all seem to be doing okay. They weren't failing. They were
Yeah.
just
I've
Yeah,
looked at
yeah.
2 in Bainbridge and they were both fine. All right.
Yeah.
Yeah, there was something else I was going to say about that, but the operative word is bias.
Yeah.
You know, it's like
100%.
it's hard. It's a
Calling it.
hard thing to get around. But you know, for the system I developed, where I really wanted that heavily insulated bubble down into the ground, the wood foundation was perfect for it, and continues to be perfect for it. But all right, so what have I learned? I've learned houses are built for the house. I don't build houses for my clients. Yeah, I have to pretend, but basically, I'm building them for the house. Hopefully, it will have many owners over its lifetime. So you kind of have to steer your client a little bit when they want 20-foot ceilings and they want XYZ. But at any rate, air sealing, big one, right? Lots of
Mhm.
important things, but it's hard to beat air sealings for importance.
Yep.
Wood foundations, unvented crawl spaces, vented roof structures. I'm not a fan of plaster and foam on roof sheathing. Sorry. Cellulose fiber insulation. Fiberglass is not insulation.
No, it's air filter.
It's an air filter, a really
That's
good air
right.
filter. Minimize can lights in the building envelope.
Yep. And we've got that now. You got little wired LED
Yeah,
things that look like can lights, and you can stick them on with double stick tape, and all you have in a penetration is just
the
a
wire. Right?
wire coming
Yeah,
through, and you can
yeah,
seal
awesome.
that. And if you really want to go crazy, put a battery one up there.
No skylights. Minimize vaulted ceilings. You want to reduce volume as much as possible. I even built houses where the bedrooms all had ceilings went from 8.5 to 7 feet. So you again reducing that volume in some of the room that you don't heat it very much anyway, or don't not to the same level as the rest of the house.
I got a grandson that's 6'5",
Yeah,
Charlie.
yeah.
And then we had another guy come in, live with my son while they were playing basketball, and he's 7 foot. So I don't think he'd enjoy your
Nah, he would feel a
7 foot
little
ceilings.
tight in there.
Yeah, he has to duck under all doorways.
Yeah. So walls and roof that minimize thermal breaks. Minimize gas appliances. Should be limited to direct vent if you're going to have gas appliances. Soil gas mitigation. I don't call it radon. I want all soil gases kept out of the house. HRVs and ERVs, metal roofs, no exposed fasteners. Low VOC finishes, no carpeting, emphasize conservation over gadgets. Don't do with mechanical systems what can be done with passive systems. Tank type water heaters. I'm still a fan of tank type water heaters. Super insulated conventional. Carbon dioxide type heat pumps. Any kind of heat pump is okay in my boat, but you've got to realize some of the drawbacks of conventional heat pumps. It's just Allison Bales just sent out a thing today on his blog about 120 volt heat pump water heaters that are a thing. That seems kind of interesting. Less is more. All right, so that's
Charlie,
kind
I
of
like the ducted mini splits, but we do have to keep in mind dehumidification is pretty important. And some of those mini splits are not quite meeting the they're just not doing what we thought they were going to do on dehumidification.
But see, these houses don't need hardly any cooling or heating to begin with. So we're looking at something to supplement that
Sure.
ground temperature. So
Okay.
yeah. In a conventional house, that's kind of an interesting thing that I learned early was how a really expensive active solar system would pay for itself very quickly in a poorly insulated, air leaky house where they would never pay for themselves in a super insulated house.
Right, right.
Kind of interesting.
Well, when we poured the slabs in the big rooms that were passively solar, and we were wanting those slabs to be our heat sink, and then guys started putting radiant tubes in them, totally ruined the concept of a heat sink, because
Yeah,
now you're
yeah.
actively heating it.
Yeah, it's there's conundrums to no end, but
Yes.
so that pretty much gets us through the energy part, and then I thought I'd just share a few pictures of other stuff I've entertained myself with over the years. Uh, some odds and ends, and what did you look in 1969 like in 1969? That was me in a little coffee house in 1969. It kind of all started with kitchens. For me, I was building kitchens in houses before I started building houses, and so this is my kitchen, our kitchen. Julie's in my kitchen. But notice I've got a pineapple way before there were requirements in Zoom backgrounds. Have you seen that in Zoom backgrounds? You had to have a pineapple. I don't see your pineapple in yours, Tessa.
I didn't realize that was a rule.
Yeah, it was
I
I don't
apologize.
know where it's a thing. I think it was a thing on PBS maybe. Julie, where was it a thing? Did she got her? I think she's got hers there maybe.
Is this a hospitality thing?
Yeah, it's
How to
how to
zoom
zoom
your
your
room.
room.
Yeah, how to zoom your room. And there's actually a picture of a pineapple on the binding.
Yeah,
So
yeah, you got to have a pineapple in the background.
I'm distracted by the tree that I see in your kitchen.
I know.
Yeah, you got to have a madrone in your kitchen, don't you? But here's a fun little thing. This
That was
glass.
a pole, Tessa. That was before pole dancing was popular. That's an old one.
God.
Right in the kitchen.
So
Well,
this
we just took this one to another level.
So this glass tile that's set into this marble top and a breakfast nook, it came a Windex color. And the Windex color wasn't the right color for the kitchen scheme. So and I found this Windex bottle in some house years and years ago. So I still have this unopened Windex bottle from the 40s or 50s, whenever they started making Windex. But at any rate, so what I did is I put orange grout behind the glass to bring it up to more like the color that would go with the kitchen. So that's kind of some of the kinds of fun.
Charles Buell, builder and artist.
Yeah.
Yeah. I'm impressed by the way you do your PowerPoints,
Me
Charlie.
too.
Yeah, well, we talked about meeting over that.
I know it.
You guys have to take his 8-hour electrical class. The PowerPoint is a total work of art. It's beautiful.
So we got a fish in our kitchen. It's a time capsule that has a bunch of stuff in there. I can't remember now. Some coins and tickets to Sounders games and stuff.
Nice.
This picture reminds me of those games where you're like trying to spot all those different hidden items in the
Yeah.
picture. Like, spot the pineapple, spot the fish, spot the tree.
Yeah.
Yeah, the tree. Everybody's got to have a drone in the kitchen. At any rate, so
Tessa, you'll never see the pile of junk that Charlie took out of the picture.
yeah, I know. I totally
Make
had
this
to.
part of the presentation.
I had to clean up the kitchen a bit. Trust me.
You know, look in my
I
bag.
came home from a week away and there's this big pile of junk in the living room. I'm like, in the dining room. I'm like, what is this? Oh, okay, I get it.
From the kitchen.
Yeah,
These are the things that make PowerPoints take so long too.
Yeah, right.
yeah.
Gotta clean my kitchen, then take the picture.
Yeah, so here's all the insulation holes. Any building we build, we'd always climb all the way around the building on the insulation holes just for
OSHA
fun.
approved.
Yes, yes. And this was my big pet project, Stone Gardens climbing gym. It's now called Edgeworks, but I built all that.
Wow.
Big project.
Hmm.
Let me back up one. This tower here is this next picture here. That's this one here. So some of the pictures you'll see will be looking down inside of that, but there I put a few holds on the wall for scale to give you a sense of how big this thing is. And there I am climbing on that. But just some of the walls. This was some hardware for the climbing to protect you from falls. This was a system I designed, and Julie's brother did the engineering for it, and so we installed all that throughout the whole gym. Every double nut was sealed with red paint so they could check them periodically. It set up a whole yearly check schedule. They had to check off every single connection. There were like 3,000 connections they had to check off every year yeah, they're still there, still haven't moved. But there's a typical sport climbing hanger this would be on the face of the wall, and this is the bracket system that so they could be all connected together. You can see all these threaded rods that connect them together. These are called T-nuts, where you would screw the individual holes onto the wall. All fun stuff. There's some more here. See how this is a beam that these connect to, and there's a threaded rod that goes to a hanger, and then another threaded rod to another hanger down below. So sometimes you'd have 4 or 5 of those together. This is my water heater. It's my R40 plus insulation on it. You can see the regular heater buried in here, and it's got 2-inch layers of polyisoanate around it to get it up to R40.
So you strapped on the outside of the foam?
These straps,
Yeah.
yeah, they see every one of these, there were 2-inch piece cut tapered so that they had to have the right taper that when you wrapped the tank with them that they all had no spaces in between.
Yeah.
So that's how they worked. So I've got a piece of tape on here and an IR image shows you how hot that tank is in behind the 2 layers of foam. And every water heater is doing that 24/7, whether you know it or not.
Did you name that R2D2?
Yeah, really. Yeah. So the tank came R16. So you got an R16 on a tank. You got to keep at 130. I keep my tank at 130 degrees, and then I have a tempering valve to bring it down to 120. But to keep a tank at 130 degrees, and it only needs R16. Why do we need R19 when we're trying to keep our room to 68? So at any rate, that's my thinking about it. People tell you it doesn't pay to add this to it. Well, it didn't take long for these 2 layers of foam to pay for the savings on this. I have a meter. I have my tank metered. I know exactly how much electricity it uses and how much it has saved to do this to it. So it's got 2 layers. That gets it up to our 42 plus a little bit. You get a little bit for that nice airspace in there, but generally that's pretty close. Let's see. And then this is another whole thing of. I had a buddy that built a bunch of houses with curved walls, and he had me do some paintings for those curved walls. And I've got one in. I wish that David was here. I have one on Marco Island in Florida. There's several in upstate New York, but this was the idea. He would build the walls, and I build the curved paintings and provide the paintings for his clients.
Do you always leave behind one piece of art in each house you build somewhere?
I usually hide something.
That's
Yeah.
awesome.
like what, for example?
Oh, like nailing a dollar bill under shingles, or
Okay.
I've I like time capsule type things. Yeah, lots of houses. I don't even remember what they were anymore. But I house plans sometimes stick them in behind a fake panel in the kitchen, or just something that somebody will find interest in it when the house gets torn down or whatever.
I'm
The
not
wood
surprised.
foundation? What?
Yep.
Sorry?
What's that?
What about the wood foundation getting torn down?
Yeah. Yeah, so far none have been torn down.
I like it, Mark.
So that's the end.
I had a question on the on your hit list. That last slide before you got into this cool stuff, you had carpeting on there, and I didn't get to hear what your thoughts were on carpeting.
I don't like carpeting. I think it's it's just it's really collects a lot of for indoor air quality. They're really bad. Dusty can attest to that, I'm sure. So I just don't want carpet in a building, but I know a lot of people want that, but I don't.
Yeah, I don't know if you guys have ever heard of Mac Pierce or McGregor Pierce. He passed away a couple years ago, but he was an indoor air quality and actually like a mold expert. But you know the mad scientist from Back to the Future.
Mm-hmm.
He's that guy in real life, and he was awesome to listen to. But one of his biggest things was like, carpet is nasty. Like if you
it's evil, right?
Get rid of it. Yeah.
My favorite is when they would put it in bathrooms back in the day.
Yeah.
I mean, it was so horrible.
Yeah.
I mean, you sort of like leap back when you go into the bathroom. You know, like I don't even want to inspect in here. You know.
Hold on, guys. I'll mute.
Yeah.
Yeah, anytime I do any indoor air quality stuff, if there's carpet, I mean, that's just a huge asterisk in my report that carpet's going to affect anything, especially if you do any sort of sampling and you walk across the carpet first. I mean, you just keep all of that stuff in the air. So yeah.
Yeah, and
Carpet's
and then add pets to the house.
Yep.
Yeah.
It's yeah.
Yeah. Well, thank you so much, Charles, for this awesome presentation and sharing all your wisdom. I put a couple of my thoughts on your summary points in the chat feature, but I appreciate your unique perspective on a lot of things that are kind of counterculture.
Yeah. Don Quixote, right?
Yep.
Yeah, you're the best, Charlie. I'm so sorry I came late, man. I had it down for 5.
Yeah, well, that happens. But
Hey, you may have covered it, and maybe I just missed it. Did you talk about insulation on exterior walls? I know all of your installations inside of your wall, but I was wondering why you didn't do anything with exterior wall insulation.
Well, except for on the wood foundations, that you're going to have some amount of blue board or something below grade. I don't know of an easy way to get to R48 without doing that. And it also adds protection to the wood foundation. So I didn't really talk about that, but a lot of my foundations, you tar and polyethylene the foundation, and then I would put 1/2-inch Celotex board over it just to protect it during backfill, and knowing that it's just going to rot away eventually.
Well, Charlie,
Yeah.
when you were building, foam didn't come out until about the 80s. I remember getting the first piece of foam, and in the wintertime, remember the silver, and it just made our job sites just a mess because the sun would shine on it and melt all the snow. And my goodness, what a miserable mess that was in the wintertime.
Well, that's
But
another
just
selling point about wood foundations. You're out of the mud immediately.
yeah.
Yeah, so these houses kind of predated like accessible like insulation foam board, and so you were just thinking of
Well,
reduced thermal
it
bridging.
came along. It came along
yeah.
in the 80s, in the
I
early
mean,
80s.
Yeah.
the house, it was pretty early. All the houses, that 1976 house, I built 2 that year, and we had foam board in those.
Okay. It was
Yeah.
kind of new though, Charlie, in
Yeah.
76.
You know, because
very,
there were all
very
the
new.
arguments about whether blue board or white board was better, and of course, blue board is better, but they have found that even blue board over 30 years will take on moisture.
Mhm.
Some guy
Yeah.
didn't.
It just made me think about that when you were trying to figure out or talking about sealing or the seal plate for the house and how to get that insulated correctly. I thought about exterior insulation, maybe accomplishing that goal.
Yeah, I think there's ways to deal with those. I mean, my walls now have only very isolated instances of where it's necessary to deal with that to break that thermal break. I can back up to, I don't know how far back I got to go, but
To the 1980s.
yeah, really, go back to another time zone, Twilight Zone. I think that's where it is. So, like right here, you see how by cantilevering this over, this ends up all insulated. And then this foam covers this weak point here. So really, other than the sheathing subfloor that goes all the way to the exterior, there's not much to break thermally anymore in these. Same with whether the wood foundation, not much wood through anymore, right? So pretty broken up.
Charlie, do you like the exterior insulation if you were retrofitting? I mean, that's, that's where I'd see foam more like people trying to make older buildings more, get an efficient wall assembly.
Absolutely. And why you can't talk about them in the same PowerPoint. You can't
Yeah,
talk about
it's a whole different deal when you're
old and new. You
retrofitting.
just can't talk about as being anything alike, or that the same solutions work for both. When you're talking about trying to bring a 2x4 house into the 21st century, it's almost better to bulldoze it. I just
we wouldn't have any houses left.
I know, but if doesn't it upset anybody that we're still building dinosaurs? We still are. Every day I drive by and see somebody building another dinosaur and that's how I started with my very first house. The guy asked me and said, "Hey, you want to build a house?" And I said, "No, because I'm just not going to build another dinosaur." And I was fighting for a 2x6 house at that time, 1975.
It is interesting. I mean, I remember watching I think of like This Old House, and this guy had this crazy hydronic heat system in his house in Germany. And, you know, it turns out that he was like the fifth generation that had lived in this house. You know, and it's like it was really cool. I mean, he had this totally different point of view of like how long you were going to maintain a house for, and like you know, he had no problems investing in things that might last 100 years, and that just doesn't in any way fly in America with like
No.
that sort of,
Well, we're
you
we're
know,
babies. We've only been around for a couple hundred years, and they've got buildings that are centuries old.
Yeah,
Well, thousands of years, thousands and
yeah,
thousands
they
of
have
years.
much higher energy costs and they don't move around so much. So like it's fascinating. But yeah,
What's
our
your
houses definitely reflect that sort of quarterly profit. I'm going to move in 4 years
yeah?
mentality, you know.
You know, that list of things I started with that are impediments to building. I should add entitlement to it.
Ooh. Woo. Hey, I gotta run, Charlie, but it was great to see you guys, and thank
Yeah.
you so much for this presentation. It was really fun.
Yeah,
Thanks.
super cool.
Thanks for helping out, Tessa, and
All right.
great to see you. All right.
Yep. See you later.
See
See
you,
ya.
Tessa.
See you
Bye.
later. Oh, I gotta get out of here myself, Charlie. I got
Okay,
3
Mark.
reports I should do.
Hey, I'm glad to see I got Dusty. Dusty stopped multitasking for us.
Yeah,
Yeah,
nice to see
yeah.
you, Dusty. Super cool.
Yeah, I had to jump on over into it. I've got like 4 reports to do, but you know, you
Yep.
set precedent for me, so I'm here.
Hey, I'll
Nice,
give you a
man.
5th one.
And
All
Mark, got 2 Marks, Barry and Dylan. Great to see everybody.
Take
Thank you
care,
for
Yep.
guys. Good to
Thanks,
see you.
Charles.
All
And
right.
Julie, nice meeting you finally.
Yeah.
Yeah, nice to meet everybody. Nice to see everybody.
Yeah.
Come
All
visit
right.
sometime.
Yep.
Charles, have you ever heard the phrase outkick your coverage?
Outkick my coverage. What's that mean?
Never heard that.
Or
No,
marry up?
Oh yeah.
It's a
That was a
Yeah.
compliment.
to you,
Julie, that was a compliment.
Oh, that's great.
Yeah, trust me, I know what I've got.
Well, I tell you what, don't tell us about the pole in the kitchen. Okay.
It's
Julie, I
really
just brought-
smooth.
Julie, I just brought a new vision every time you walk by that tree.
Yeah. No, I really appreciate that he was doing this presentation because the kitchen was just immaculate when I came home.
No,
When I came home from a week of hiking in Colorado, I couldn't believe my eyes. And
Well,
But not the
maybe
living room, though.
maybe
It was all just moved over to the living room, right?
yeah. Then I
It literally
then I bought
was
the
just
next
piled up on the dining room table. And
okay.
that's great.
Next session in the living room.
All right, guys.
Hey, we'll see you
Hey,
later,
guys.
guys.
Take
Bye.
care.
Bye.
Bye.
Bye, everybody. Lovey?